Hi everybody, today we're going to talk about systems of linear equations, and this time we have 3 equations and 3 unknowns. So pretty much what you're going to see with 3 equations and 3 unknowns is that we add the variable z to our system of equations. So I'll have an x, I'll have a y, and I'll have a z. And what will happen is we will have a point that has 3 coordinates, so x, y, z, kind of like we've been writing x, y, but now we add this third one in there, which is z. In practicality, this is super important because in life we have a height, and that z really kind of represents the height. So I want you to think when we're looking at position, height is also important to consider. XYZ, instead of just forming a line, forms a plane. So what we're looking at is how do planes intersect? If I had 2 planes, they would intersect and form a line. When I throw a third plane in, it is going to make a point. Of course, there are different conditions, but we're keeping this pretty simple in this video. So we're going to start with the simplest thing I can think of, which is just a little backward substitution. So I have 2x plus y minus 5z is 14. I have y minus 3z is 4, and I have z is 2. So because I know what z is, I can put it into the second equation. So I'll have y minus 3 times 2 is 4. This says y minus 6 is 4, so I know that y is 10. I know z, I know y, let's go for x. I have 2 times x plus 10, which is y, minus 5 times z, which was 2, is supposed to be 14. 2x plus 10 minus 10 is 14. Well, these 10s cancel, let's get rid of them. 2x is 14, x is 7. When you write your point, you write it as x, y, z. So x is 7, y is 10, and z was 2. Let's make that a little bigger. And how this is really bigger is I don't know one of the answers to start. I have 4x plus 6y is 22, 8x plus 7y minus z is 31, 12x plus 7y plus 3z is 27. Overall, our strategy is to go from 3 equations with 3 unknowns down to 2 equations with 2 unknowns. We take those 2 equations, 2 unknowns, and we get down to 1 equation with 1 unknown, and we solve. So I do have this little hint that when I look at this first equation, 4x plus 6y, it doesn't have a z. So I think, could I get rid of the z using the other 2 equations to kind of help me out? So I'm going to multiply the 8x plus 7y minus z is 31 by 3 to get a negative 3z. So I have 24x plus 21y minus 3z is 93. I still have 12x plus 7y plus 3z is 27, and I'm adding this together. So 24 and 12 is 36x. 21 and 7 is 28y. 93 and 27 gives me 120. So now I have a second equation that doesn't have a z. So I look at the 4x plus 6y is 22, I look at the 36x plus 28y is 120, and I think about getting rid of one of the variables. I look at 4 and 36, I look at 6 and 28, and I think 4 and 36 look better because I can just multiply the 4 by negative 9 to get negative 36. So that's what I'm going to do. I'm going to multiply this whole first line by negative 9. Negative 9 times 4 is negative 36x. Negative 9 times 6 is negative 54y. And 22 times negative 9 is negative 198. I add that together. The 36x cancels. Negative 54 and 28 gives me negative 26y. Negative 198 and 120 is negative 78. I divide by negative 26, and that tells me that y is equal to 3. So now I have one value. From there, I start moving backwards. So I do have this 4x plus 6y is 22, and we just found out that y is equal to 3. So we can plug in the y. So I have 4x plus 6 times 3 is 22. 4x plus 18 is 22. Says 4x is 4, x is 1. So let's grab one more equation. Let's use 8x plus 7y minus z is 31. And we have 8 times 1 plus 7 times 3 minus z is 31. This is 8 plus 21 minus z is 31. So 8 and 21, 29, minus z is 31. That says negative z, 31 minus 29 is 2, so z is negative 2. My point is 1, 3, negative 2. You can see this is getting longer, and we did have one step done for us already because I didn't have a z for the first equation. So the bigger this gets, the more steps we're going to have to do. I have some good news. There is a shortcut. We're going to use something called a matrix calculator, and we're going to use the Desmos one. There are other ones out there, but I use Desmos the most. So what we do with that is we come back to our original set of equations and we just write the coefficients. So I had a 4 in front of the x, a 6 in front of the y, I had 0z, and that was 22. Then I had 8x, I have 7y, I have negative 1, and then I have 31. I have 12, I have 7, I have 3, and that's 27. So we are going to put this in something called a matrix. Biggest thing you have to worry about with the matrix is how big is it. So you look at there are 1, 2, 3 rows, and there are 1, 2, 3, 4 columns. So my size is 3 by 4, and then I'm just going to put in these numbers. So start off, this is Desmos matrix versus Desmos graphing. So they do look a little different, but I want you to look up Desmos matrix, then it will come up. And we're going to start by forming a new matrix and see how it says, like, what size do you want? So we said we want 3 rows and I want 4 columns. So that gives us a place to enter all of our numbers. So I'm entering 4. Hit tab to get to the next number. Don't hit enter. Enter will go to a whole new line. So you want to hit tab to move around. So 4, 6, 0, 22. Again, tab to the next line. I have 8, 7, negative 1, 31. Last line, I have 12, 7, 3, 27. Once you have it all entered, you can hit enter to go to the next line. Now, the important key to have it solve for you is you hit this button RREF. That stands for Reduced Row Echelon Form. I'll show you. So I hit RREF and I hit A. It named the matrix. What this tells me is the first column stands for x, second column stands for y, last column stands for z. So the x is equal to 1, the y is equal to 3, the z is equal to negative 2. That's all you have to do. You plug in the values, you go to this calculator, it spits out the answers. So 1, 3, negative 2, just like our 1, 3, negative 2. So use technology to help you out in this section. This is so long to do by hand. I will do another one by hand so you can see what it looks like, and then I'll do a couple more in the matrix calculator so you know how to set it up. So this says x plus y plus z is 9, x plus y minus z is 1, 2x minus y plus z is 5. You start by looking and thinking, like, what could I get rid of? And z looks really good because I have a plus z, I have a minus z. So I'm going to start by adding these two together. So x plus y plus z is 9, x plus y minus z is 1. When I add, I get 2x plus 2y is 10. I'm going to do that again. I'll add these two. I have x plus y minus z is 1. I have 2x minus y plus z is 5. When I add, x and 2x is 3x. Y minus y disappears, which is great. Negative z and z also disappears. Awesome. 1 and 5 is 6. That says x is equal to 2. X is equal to 2, so I plug it into this 2x plus 2y is 10. So 2 times 2 plus 2 times y is 10. 4 plus 2y is 10, says 2y is 6, y is 3. So the last thing I need to do is find out the value of z. I know x plus y plus z is 9 from my first equation, and we found out x is 2, y is 3. We just need to know z, and then we'll be done. So this is 5 plus z is 9, z is 4. So my answer is 2, 3, 4. Let's do the matrix calculator on this one also. So I'm just going to write down my matrix. I have 1, 1, 1, 9. So that's 1x, 1y, 1z. I have 1, 1, negative 1, 1. I have 2, negative 1, 1, and 5. Same size, 3 rows, 4 columns. That part won't have to change. So I cleared everything and I'm just going to start again and say new matrix. I'm going to do 3 rows, 4 columns, and then I'm putting in my numbers 1, 1, 1, 9, 1, 1, negative 1, 1, and then 2, negative 1, 1, 5. So I have my matrix, I hit enter. Our REF of A says 2, 3, 4. So we're really just reading this last column to get out your answer of X, Y, Z. And once again, you can see it's the same thing we got. If you wanted to, you could also do this in the TI-84 calculator. You have to do a few more steps, but I'll show you just in case you have this calculator. So the first thing you do is you find the matrix, which is here, and you pick which one you want to use, and you say edit. Just like it did in Desmos, it says, what's your size of your matrix? And you say it's a 3 by 4. Then you put in the values. With the TI, you do hit enter after each number. It's just a little different that way, but I just keep going through all the values, just like I did with Desmos. So 2, negative 1, 1, and then 5. After it's entered, you have to kind of quit and go back to the main screen. You hit the matrix again, and you say you want to do math, and you have to go through the list until you find our REF, so that is letter B. You put REF, and you say which matrix you would like to do our REF to, and that would be to matrix A. When you push enter, you get 2, 3, 4. I show you both ways just to say this is something you end up doing a lot in other classes. So a lot of science kind of classes will have systems of equations you have to do. You need to find the point of intersection, and it's good to know how to use technology to get that answer. It will take you a very long time to do this by hand. And here's my overall prediction is when you get to those science classes, it's not going to look as pretty as XYZ. It's going to look like 0.8x plus 0.8y plus 0.8z is 2.4, and 0.3x minus 0.5y plus 0.2z is 0, and 0.1x plus 0.2y plus 0.3z is 0.6. So you can see how this could get really messy really quickly. So this will be the last one I do, just one more demonstration of how to put this into Desmos so that you can start doing your homework. So once again, I like to clear, start a new matrix, 3 rows, 4 columns. Let's put in those numbers that we got, 0.8, 0.8, 0.8, 2.4, 0.3, minus 0.5, 0.2, and 0, then 0.1, 0.2, 0.3, and that was equal to 0.6. I like to double check my numbers. It's easy to make little typos. Sometimes you see me do that and I'll erase it. So it's just important to check for accuracy. Once I have it in, our REF, reduced row echelon form, of which matrix it was A, we get the answers 1, 1, 1. So use technology, embrace it. Don't feel like you have to do things by hand like old school. I think it'll really help to go this way.